Welcome to the Canon Automation webinar series. Today we have a webinar with the topic Drive Control. This is the update webinar from a couple of years. We have some new information. What is going on in this area? And so let's get started. In the first couple of slides, as usually, I'll introduce the company for those who are not familiar with it. And then we go through the topics. My name is Oskar Kaplun. I'm working for Canon Automation, and today I will be showing you what is new Canon Automation regarding our drive control Knopen interface. What are some recent events we have? Briefly, I'm an electrical engineer, I have a degree in that. Beside that, at Canon Automation, I perform some specific tasks. On the outside, in standardization committees, I represent Canon Automation as Knopen expert. Inside of Canon Automation, I'm operating as technical secretary, supervising multiple working groups in Knopen, classic Knopen, and Knopen FT technology. We're writing specifications in various application fields. Beside that, I'm also testing engineer at Canon Automation, do test Knopen and Knopen FT devices, do also interoperability testing, and supervise Knopen lift application Plugfest. Where the people come, developer of Knopen, lift components and host controllers and test their components for the interoperability in a lift application. Briefly to the content, introduction of the company. Then we go step into the Knopen drive profile information, what is new there, what is going on. Then we talk about Knopen FT, variation of it. What is this? How can you start with developing it? Is this something for you? Then we talk about the application. How do I design the application itself? How does it look like? What should I consider about this? Finally, we will have also some interesting topic, security concerns that affect also embedded network. We have some news for you in that matter. And finally, I will do some outline of what we've learned today and what is going up to. So, introduction, Canon Automation was founded as a support for CAN-based technology to provide product, marketing, and technical information on CAN-based technologies, promote image of CAN-based technologies throughout the industries. And over the course of nearly 30 years, in this year we celebrate anniversary, that we've collected some knowledge about CAN-based technologies and founded a big social network of the competence in area of application of CAN-based technologies. And if you need this information, you need to get some in touch with CAN-based technology, you're welcome to contact us. Canon Automation is located in Nuremberg. There is the only office, and our testing laboratory is also located in there. From this office, we operate worldwide. Canon Automation is a membership-based organization, so this is the organization in the first place. It was founded 1992 with only few handful members, and by now it is about 722 in this year. Over the course of the years, it shows that interest, at least to CAN-based technology, is still remain at large. Briefly about the history, we do have foundation time. There were a few companies, some private persons, and all the companies in a private person are still in there, still members of this organization. Is Mr. Zeltwanger, who is still director of CAN Automation organization, and the companies such as Berghof, ESD, Electronic, and are still CAN Automation members. Over the course of the years, we promoted the image of CAN on various CAN conferences. We designed specifications to support CAN-based development for data link layer, physical layer, and also for application layer that we called CAN Open. Over the years, we have arranged several exhibitions, CAN conferences, where the actual informations, actual feedback, and reports about what is new, what are new development in CAN-based area is going on. We have introduced the first testing tool to test developed devices. Then we have also designed some specific product guides, marketing assistance for our members, how to get their product exhibit, design measures for exploring new markets for CAN-based technology, and so on. We have several new technologies, CAN-based technologies, such as CAN-FT, beyond classic CAN, and also CAN-XL. Not to mention, it is important to mention that in this year, about a month ago, we have released third technology specification, CAN-XL, which will be standardized as the previous two, and also CAN-FT Lite for light applications in the automotive. CAN Automation provides services to our members. This task performs CAN Automation company and does this on request from CAN Automation organization. Our member decide how we proceed in technical area of application, what specification, what protocols, CAN-based protocols we develop, and the marketing branch of CAN Automation company decides how do we promote the image of CAN, which exhibitions we go, which market we open. Start briefly with technical technical arm of company. We have supervising committee oversees every development of specification and what we're going to do in technical area of this one, we do kind of tests and so on, such things. And as you can see, we have various new technologies, CAN-based technology, and so we have arranged them in several working groups, also supervising development of various specification. This is our profiles that are various area of application of CAN, especially, and due to new technologies such as classic CAN Open and CAN Open FT, we have to separate them. Beyond that, we also have specifications to support our application there, and we have call them lower layers working group, IG lower layers. It develops some subsequent, doing some subsequent tasks, developing specification for this lower layer, such as physical layer and data link layer. We'll talk about drive control that is marked bold in this diagram. Drive and motion control, this working group at CiA Automation, I'm supervising this, and it is currently technology independent. So there is CiA drives and motion control, CiA interface, and it's also CiA FT interface for that. We'll talking about this later. Beyond that, some specific working group, well, specific task at hand are got into with our members. They are safety and security, where we handle all various tasks of functional safety and cyber security, and also high availability of the networks in a working group redundancy. Beyond that, we have a concept for marketing groups. We visit exhibitions, we demonstrate products of our members. We have some CAN technology demonstrators, these exhibitions. We visit our members, design presentations on a conference, on exhibitions to promote the image of CAN, to promote the recent development in area of CAN. We do design image brochures, we design videos, we design publications, various language to attract more interesting parties to the CAN-based technologies. The task at hand is developing an open specification. Around this one, we have various additional services to support device manufacturers, system designers, deciders on a corporate level, either to use CAN or other CAN-based technology through their consulting services, marketing information such as product guide, marketing tasks and events we design, also technical in the way we design such events as the webinars of today to give short overview of what we're doing here, and more detailed seminars on specific technologies as a training for our members and also for non-members, starting with development in CAN-based technologies. Beyond that, we have some additional services to support through our social networks, through our website, through our email services, our members and also non-members, to provide some information about recent development in CAN-based technologies, recent development in CAN automation, which exhibitions do we exhibit, what events do we have, such things. On our website, you can find all the interesting information around CAN-based technology. You're welcome to contact us through our email addresses if you have any further question on this topic. Specific thing we offer is the membership. It provides certain advantages, having access to all specification, have testing at reduced price, attending special marketing events such and technical events such as plug fests. Testing is done to reduce price, development of the partnership with other CAN automation members. That is all about CAN automation in general. Now let's get started into the topic of our today's webinar, technical side. CanOpen drives and motion control profile. As I said previously, drives and motion control interface is now generic, more general, and we have not only classic CanOpen technology that you could design with that, but also CanOpenFD. This is all we will talk about today. But we start with CanOpen. First of all, when you start the development, you scratch the head, say, where do I start with? I need first of all to see the requirements. They can be found as usually in the specification or in standards. Please bear in mind that this specific specification for CanOpen drives is also standardized one. We recommend to use the standardized one, although recently the recent second version of the standard for CanOpen drives is also available for our members as the usual specification called CiA 402. This is specification that you can get from our member. We are currently in a process of release, the next version, which also will be standardized, but will take some time to do so. We're working with the Standardization Committee. For the moment, the specification is a process of the release with all new information, no new updates, new functionality, which I will talk you through today. It consists of 5 parts by now. The very first 3 parts are also standardized in a standard IEC 61800. Check this later on that. And the first 3 parts, as I said, they are exactly put in a standard. Part 4 is CanOpen safety and Ethercad safety. They are not standardized. There's just a specification, which means, that for the case that you would like to design them, you have to become our member to get access to the specification. And for CanOpen safety, you have to discuss every step of your development with such functional safety authority as, for example, German TÜV. Additional video mapping superset designed for synchronous and asynchronous machines came later on. It is not included in a part 3 and is only available for CanOpen and the working group that, as you can see here, special interest group, which maintains these specifications, drive and motion control group, decided as CAN Automation members, we do not need any such superset for other CAN-based technologies. That is sufficient for CanOpen and shall stay in there. I would like to also mention PLC Open motion control, which is specified a CanOpen interface for that. We have not designed CanOpenFD for this case for the moment because PLC Open technology developed in joint work with Schneider Electric is currently in a stable state for over a long time and no changes are expected. So these are specifications which you could take if you start development. Drive control with CanOpen interface, even if deeply embedded system, you need to start with these specifications. Device profile, we said this is device profiles. What is this? How do I handle? For those who do not know yet, what is this? This slide shows a small example of typical CanOpen network. related to the drive control, and you have seen in this device downside in the network. This is CAN network. This is actually CAN-open network because devices have CAN-open interfaces. On the top of this is a PLC having CAN-open manager and network management capabilities. It is a distributed system. It allows us to perform the task for PLC, the general task of network management. On the other hand, in a distributed network such as this, CAN-open devices from R to D, for example, they perform their single task even independently, and they simplify their communication in the network, and they can handle several tasks completely independent from the controller, from the PLC in this case. Thus, the distributed network has an advantage with. So just for example, CAN-open device R illustrates an sensor network, whatever it might be. It looks like I/O modules, but it is not entirely that. Device B is our drive. The motor can be attached to this, but it is drive controlled in there. Drive also has some various additional components which might be included into one device, or maybe hanging also on the network, providing this information centralized or just provided to the drive to make it perform the drive control. So CAN-open device C is a modular I/O system, which allows us to do some additional communications. This is an example of simple network. We just put it in there. And CAN-open device D is, for example, position encoder, which helps to identify the position for the drive and tells him that where to move to perform the movement. So the device profile. The idea of device profile is to simplify and unify the data interface among certain classes of devices, and thus provide standardization level, higher standardization level for the device and its availability and interoperability with a similar simple network and devices from other manufacturers, and provide its effectivity for the network integration. There is also another point of this device profile has certain key features allowing to get more into details and to get to know what is this all about, what is this device I'm purchasing as a system designer, as usually devices are manufactured and sold on the market, and someone called system designer purchases them if he wants to design his system, which includes in this, like in this case, several drives, and he has to put them together. First of all, he needs to know what is kind of the drive. Is this inverter, step motor, or just generic drive profile? This is important. This object 1000 is provided here in this slide, tells this information. It tells about device type. Additional object 1029 is an open object, provides information about how the network, the device, and in the network behaves in case of device error occurs, communication errors, and the device internal errors. For the details, you can see other specification for 402 specific errors, or also, and also the base specification 301 can open application profile and communication interface. Additionally, device profile has unified video communication mapping parameters, so you know this process data as CANopen protocol allow you to transmit or receive specific data. It is not limited, it has a default settings for their default parameters that you could use, but it doesn't limit you. You can design your specific network. What does it offer as a device profile? If you have a default mapping, default parameters, this means that plenty of devices, you exactly know what parameters do they submit, what parameters do they have actually, and thus I know if I connect, I have very little effort to design my system and little effort to configure my system. Additionally to that, the standardized application object specifically for drive, not for encoder, not for I/O module or whatever might be, but specifically for drives, allows you to have purchase on the market the very devices you specifically need for your network. A little overview, how do I read this object 1000 by using CANopen protocol STO or CANopen FTA protocol USTO. With only one access, I can read that the device profile is the drive profile 402. I can read the type of the device. What is this actually? Is it generic device or step motor or whatever it might be? The types are defined in there. And I have additionally 8-bit of modes identify my specific uniqueness of my drive. The 3 more slides will show you how and what are the key features actually of the drive profile. Why should you select it? Why should you use it anyways? So in the first place, standardization makes the devices development of the devices and selling them on the market extremely effective. They provide degree of unification. You could purchase from the market the device and know, okay, is compliance with standard. This means that integration to network will be done with a relatively very little effort. The data interface is also the same. So if you purchase device from different manufacturer, you have to replace the device. The standardized device is exactly what you need because it contains exactly what is standardized. It is most implemented solution for CANopen drives over the course of 15 years, even more. Drive profile was implemented multiple times. The support is very big. We have a knowledge base of how to handle specification, what are specifics in development of this device, so on. And so did the real developers. They have their knowledge about this. They could share their knowledge with the others and helping them to implement drives. There are 4 basic types of drives you could design. Non-specified ones you could design as well. This is the point you have to exactly look into what you map into these devices. The devices, standardized devices, as I said, give a very big degree of standardization in there. You know, you purchase this on the market and you will have exactly those application features that are standardized in there. The footprint, a software footprint is very small, relatively small for drives, even it is quite a big one. But as usually it allows you to design a very tiny implementation, very few functionality, very little functionality. Still, you operate fully blown 402 drive. There are several manufacturers only of host controllers with open communication interfaces and 402 devices. So you go to the market, see 402 device, or even standardized IC 61800 device with an open interface, and you know exactly, okay, this device should be also compatible with my network if I'm expecting 402 network. Second key properties, go into details. State machine of the device itself have various options. You have all the flexibility you need to do so. There is extensive diagnostics provided in specification. You could have access to special parameters and get information what is going on. There are multiple operation modes, such as position, velocity mode, torque mode, whatever you need, and also combination of those modes, synchronous, cyclic modes, and we're still developing and introducing new modes into the specification. The process data object is an open service for broadcast messages from one to everybody participant in the network. Accommodates in a very small footprint, control word and command value, only control word or status word depending on its purpose, and more advanced are using also additional command values or even process data such as position or velocity values. PDO mapping is generic, can be type specific, so the flexibility is there. You have to choose very carefully what to do so. And configuration is, thankfully to the application parameters, is a little simplified. Although if you design your application with device, it's still you come with a device with only basic PDO mapping. You could completely redesign depending on what the device designer allows you to do. You will have to arrange this for your network. Finally, the update of today, what we do have right now, what is the version that will be released. We have 64-bit process values, this actual position. We had 64 process data, position data, and velocity as the initial requirement to this new specification. But since such precision is not really required in internal calculation and scaling of the position values anyways, we reduce this just for external 64-bit process value, which will be scaled down to the 32-bit and thus can be, however, used in internal network as 64-bit and can be transmitted using PDO, even in classic CANopen. The new thing is that CANopen FD technology is updated in there, so you have PDO mapping in there. There are additional operation mode introduced, the older ones extended. There is a PDO mapping for 64-bit process value. although we have not introduced full-blown 64-bit process data yet. Finally, we have precise drive positioning using camshaft. That would allow you to get exact positioning. In the next few slides, I would like to go into the PDO mapping itself. That if you knew about this, you can skip this slide. If not, there was still something that might be helpful and useful for you. I've just shown here the example of default mapping. If you use it, node ID 1, this is then TPDO1 only shown in there. The first PDO, first transmit PDO. This is the PDO which is designed in the device itself, and it has only the capability of configuration. Is only configuration property of the device. In a network, you see only PDO, only a CAN message that is transmitted. It is decided in the device, either this message is transmitted to the bus, to another device or many devices, or it is received. Depending on this, we call it T or R PDO, transmit and receive PDO. So this purely configurational property of the device. So the device transmits status value in this first TPDO. In a very two variations of PDO mapping is provided in the slide. In practice, practically there are many of those, several of those. You could carefully choose depending on a kind of device, which process data you will use. So you have process data 1 and process data 3, two variations. The first one includes only one transmit PDO or a corresponding receive PDO, just transmit control word, receive control word, and transmit status word of your drive. That's all. No forward data is necessary. If you design more advanced system, you would like to submit also goal position, which you would like to reach, target position, something, or you would like to submit the actual value. Then in this case, you could use mapping variation 3. The PDO is a very effective way to do so. These broadcast communication services of communication model CAN-based and is used effectively in CANopen. This is pure CAN-based data inside. There is no control overheat in the data content of the message, so the message can be going to straight to the target device. So one device is always producing, other devices are consuming. How many of those can be? It could be one, many, or all devices could be consuming. Is marked here in the color. Yellow color says this is device produces process data, and red shows that consumes. Only transmission of the data designed with the linked PDO, meaning the data transmission of CAN message transmit over this network, has only one identifier, and only on this identifier the other device could recognize, is it a message for it, and is it this TPDO, is it configured as transmit or receive in this device. So basically about this concept, how PDO operates in broadcast and so on. Then we have some additional services which you might find useful. As CAN automation member, you have access to conformance test 2 for CANopen devices. 402 can be tested as well, although we have not specific test cases for 402 specification, 402 functionality, but we test this device from the CANopen point of view. Is it conform? Does it support CANopen protocols correctly? This one thing. Another thing, we do also PlugFest. In the past, we did those or interoperability testing with 402 devices, where you could check how the device operates in the real network. For example, could be participating in fully blown, fully configured network as a test device and see is it complies with dynamic requirements of the network, timing concerns, process data transmission in time, reception of the data. Such things can be tested in a PlugFest. And also we offer interoperability services testing for such devices 402. You're welcome to contact us on this matter. So that is so far about CANopen side of drives. If you come up with CANopen FT drive, then it is necessary, unless you know about this, what is CANopen? CANopen FT. CANopen FT is a new technology based on CAN-FT frame. This is further development of CAN, classic CAN. And as you can see from this slide, there are some additional things, additional properties designed in this CAN-FT frame, which led its time. It is already standardized even in 2015. And CANopen FT is also released a specification, general specification for that protocol, and it is used CAN-FT frame. What is different between classic CAN and CAN-FT? From one point of view, from one side, it is higher payload, up to 64 bytes comparing to 8 bytes of classic CAN, and also higher speed available for data transmission. Although in this case, it is considered to make them both more or less compatible, at least decide which one should be sent. It has also the same way arbitration phase and the data transmission, which allows to transmit data much higher speed, has some specific functionality. It can be transmitted much faster, although we have to sacrifice some bit detection capability of CAN in this case. So the bitrate switching to the higher bitrate is occurred here, and so on. There are slight differences. I would like to point you out that there are in total, for right now, 3 CAN-based technologies specified. Except CAN-XL, all of those are also standardized in IEC 11898-1, and CAN-XL will be also standardized in a couple of years. This slide just illustrates how the CAN technology evolved over the years and what does it offer in key features, such as payload and throughput. This means the frequency of rate of the effective data transmission there. CANopen FT is based on CAN-FT. There are some certain key properties, such as universal STO, which is only available in CANopen FT and not available in CANopen, classic CANopen. Has some basic features, allows you to transmit much larger data, allows parallel access, allows, in comparing to classical CanOpen, STO services, not only unicast, but also multicast and broadcast communication. A couple more slides show you how this looks like. I don't need to keep the same size of confirmed messages in this case. So I could do this reduce traffic by this means because USTO is also as STO is confirmed service. So I need 2 messages for that, one to send with a request and one confirmation that the data is either received or transmitted. This latter message could be reduced to very small number of information in there. In contrary to PDO, due to the number of effective bytes in there, the configuration of USTO service is completely stored and pushed into the data content itself. It's free the user actually from this configuration overhead whatsoever. There is also an opportunity using so-called routing, creating virtual networks within one physical network. So this USTO is used for as STO in a matter of speaking for accessing of the object dictionary of the device and also accessing of the process data, and it could be used at least as this one. If you going to design CanOpenFT drives or would like to have interface, I would discourage you to combine CanOpen and CanOpenFT network in one, or devices in one network. They are not working together. You need a gateway or at least similar things in there to do so. If you design CanOpenFT, it is recommended that you have a separated segment, do this completely in one different network. What do you need for that from the specification point of view? So to keep in mind, as I said, we have arranged the working groups by a different way as we did earlier. We design them by profiles, meaning they have technology independent core, such as operation principles, operational design features, functionalities, and application data, which is valid for any technology. Then in case of the technologies, we need separate parts, which are technology specific, defined technology specific communication and PDO communication and PDO mapping. This is also done in case of CanOpenFT. If you want to design CanOpenFT drive, then this is the same working group, but you need the same part 1 and 2 for having the parameters and functionality in there. But in case you have your PDO mapping, you need the part 6 where CanOpenFT mapping is defined. Let's check out how does it look like. Well, CanOpenFT introduces, based on CanFT, some interesting key features. A part of the larger payload, whatsoever in this case, you will have then an opportunity to reduce the number of PDOs whatsoever. So all PDOs, all the mappings available for classic CanOpen, they're about 8 something, depending on kind of device, they're up to 8 for transmit and receive PDO. They could be submitted within one only PDO. But the limit of the classic CinOpen was that only 8 bytes of data. If I need more, I need at least 2 messages. On the other hand, there's up to 8 optional mapping variations in there. What we do in this case, we put multiple data together for the one single option, but with additional information, and it comes into the process data. I show here example of the generic device, what we do need to have there as receive PDO configuration and transmit PDO configuration. What do we need to know about this? Well, they are all only mapping of the process data which are really needed in this case. So for example, if I have process, no, sorry, not process, the position control, then I need, for example, in transmit PDO, I need to send the status of my drive, then I need to transmit the actual value I have currently monitoring in there and some further information. In contrast to classic CinOpen, in maximum it could be taken up to 21 bytes of data. Although we have in classic CinOpen only up to 8 bytes of data. So see the difference. The padding bytes is an interesting feature, and it's related more on CAN data link layer. So we don't have identification of number of data bytes, but we have to encode their number that could be divided by division of 2. So starting with a number of bytes in one message, starting with 8, it is no longer follows the previous scheme, and we don't have enough bits in a control field of the message itself to reflect all the possible sizes of the payload from 0 to 64 bytes. So it was decided to make it once encode the ones divisible by 2. So the next after 8 will be 12, then 16 and 24 and so on, so forward. So the data link layer adds padding bytes to fill my payload up to the next divisible by 2 message size, data byte size. So that's important to know. Thus, you cannot recognize how many bytes you really have. Although we have some additional feature in there. For example, in these padding bytes, you see to fulfill up to 24 bytes, you have some 3-4 bytes of whatever information you don't even know to what is this. And to distinguish what is actually in my message, the padding bytes, or the real payload, real data content I need to have. CinOpenFT PDO mapping was designed by the way that you map in the very first entry, as you can see here, numbered entry, this is numbered entry, indicates which bytes are actually my use data. If I don't use those, I could put some kind of dummy objects that are also specified for the size of these dummy objects, that I just block this data in there and say, either is transmitted or received without certain data that are not supported. That is good to know. Same way for CanOpenFT, we have conformance testing for the devices. The interoperability testing is for the moment not yet there, but we're working on this. So we have discussed about CanOpen, talked about CanOpen, just given an update what is going on there, that the specification will be released very soon. I have some key features in updates in CanOpen, CanOpenFT mapping, and so on. Now we check up on what is the possible application of this drive design. You can have a medical or laboratory equipment. There's a couple of slides to this topic. This one shows entire content of CanOpen device. In this case, it will be drive device. We have protocol stack, object dictionary, and application software. In application software, I would like to handle, for example, several drive axes. And this means either this is a single drive or 3 drives, which control each axis independently. And there could be also controlling of the pipette or injector. That could be correspondingly designed in an object dictionary in completely separated index ranges for the application for each single axis. And how do I implement such stuff, especially in case of video mapping? How do I handle this in this case? That could be done by means of logical devices, where I put these logical devices index ranges into this so-called logical devices into one and the same drive, or maybe in one first logical device of 3 different drives. It depends on how you would handle this. Anyways, if we do have a logical devices, then you would require still in classic CanOpen 4 PDOs for handling these all 4 axes. Considering I submit, for example, I submit status value and target position. So the first PDO provides me for the X axis. The second PDO provides information for status board for the Y axis, and the third one is for Z axis. Additionally, the fourth may be also manufacturer specific or may be unknown. You could design this in a manufacturer specific area and say this is for injector whatsoever. This is just an example how it could look like in a view of PDO mapping. In case of classic CanOpen, if you have this in CanOpenFT, it looks a little bit different. As you can see, the total number of bytes needed for covering all this stuff in CanFT message using CanOpenFT for CanOpenFT PDOs will take about 32 bytes. There is still plenty of place remain, and it can be used for some kind of diagnostic information, maybe even for each axis or whatever it might be. This is not standardized as for classic CanOpen and for CanOpenFT. It's just my example to show you what is possible. Finally, as you see the application where how to handle the things, we go to the standardization. Standard, the 402 is standardized, not CanOpenFT. not safety, but only the basic application parameters and PDO mapping for CanOpen. It is also released already twice, 2 versions of the standard in there. We will go on with, going to proceed with the next released version of 4.02 to standardize in the 3rd version, incorporating new modes, 64-bit, 64-bit process data, and some other interesting features. You're welcome to ask us what later on what those features are. I hope that it will be done the same way as it was with CanOpen. In the past, we agreed with Standardization Committee of IEC to have identically copy of the standard back to our specification, that we could provide this to our members. So that is all about the drives themselves. Now, a few things about cybersecurity concept, or rather embedded security concept we are handling. It is not applied only for drives, and it's not specified for drives as themselves. It's just our basic general concept, which we elaborate in the recent time. We're not covering cybersecurity in this webinar and in this slide. It is not our topic whatsoever. Ours is rather embedded CanOpen network. So I will reduce my explanation into that. Even in embedded network such as CanOpen, there are problems with assuring and protecting from the cyber attacks. The attack vectors are various. They could be devices like the drives themselves, which are manipulated, tempered, whatever, and the messages transmitted by these devices over the network could be also manipulated. This means the CanOpen interface can be also manipulated. And finally, the host controller can be manipulated as well. So there's the points where there have to be points of concern. What are the solutions to prevent, or at least to detect some unforeseen changes in network behavior? Recently, there are 2 solutions, hardware and software solution. It's already one from NXP, so-called Secure CAN Transceiver, is available on the market. Basic principle is guarding of CAN IDs. Says I have only a list of CAN IDs that are allowed, or all not allowed are prevented to submit the messages in the network. That allows to protect against only several attacks, like putting the illegal messages or tampering with devices which will transmit such messages and so on, can be detected by this transceiver. The point is that this transceiver requires a special transceiver whatsoever. So the usual simple transceiver doesn't work in this case. It is, of course, the question, are these seen as a disadvantage? If you design anyways a secure network, you have to implement security measures, and introducing this transceiver could be proved useful to a certain degree. Another thing is software. It requires a little bit more finesse. There is a software CanCrypt developed by Embedded Systems, which allows to operate with key exchange, private public key, generating pairing keys over the network. That requires, on the other hand, more than 8 data bytes, meaning classic CAN and CANopen in this case wouldn't operate, wouldn't be able to use this to the full extent, if any. It's mostly designed for advanced CAN technology, for other CAN technologies supporting larger payload, such as CANFT or even CANXL. I would like to point you out that we have also interest group, a working group for safety, functional safety and cyber security, including embedded security. You may contact, can contact this working group if you have some interest to elaborate such a concepts. We're working on that. We had a couple of weeks ago, or a week ago, something. We had cybersecurity workshop. If you are interested in information papers we had there, in reports we had them from the point of view of design of such embedded system with cybersecurity consideration, talking about this CANcrypt way of doing things, an XP transceiver, secure transceiver security layer, and such things. You're welcome to contact us on getting access to these papers. So far, I'm close to finalizing today's webinar. You learned some things about 402. Beside that, you have known already some. You know now that we have CANopen, classic CANopen and CANopen FT technology, and independent application parameters in there. CANopen and CANopen FT mapping of PDO and communication interface are independently designed, shall be also independently designed. I are developed further also independently, meaning we are not leaving out CANopen. It remains, will continue to exist and be further developed, but there is also additional protocol CANopen FT available now for 402 devices. CANopen FT has its own advances, features, which are very effectively used in this profile in case of CANopen FT mapping. There is also a question of the embedded security we've discussed now. Either this applies to the network you will design in the future on the embedded level. And finally, this specification we designed and now approved by the group, we are releasing in CAN automation for our members, and we'll also work this toward standardizing as international next version of international standard. Beside that, I would like to point you out, this is almost all what I wanted to say today. I would like to point you out to our next events, there will be trade shows. By the end of this year, we will present an exhibition CAN automation. Hopefully, Corona situation in the world will go easy on us, but depending still on the local requirements, we will design our appearance on the exhibition. Further webinars you might be interested in could be found on our website. I've put those on the slide here to make it more comfortable. You could see overview of this. You can register for those on our website. You will can contact us using those emails or telephone number at CiA Automation Nuremberg. Then I would thank you very much for today's participation. It would be nice to see you next time. Have a nice time. Bye-bye.